So hi everyone, my name is Sepehr, and this is actually my first tech talk, and I'm going to be doing a little bit of like a live demonstration, so probably things will break and go wrong, and feel free to heckle. Should be interesting, hopefully. Today I'm going to talk about something that I think you're all probably pretty familiar with. It's the first thing that you see when you open your browser. It is the most common way of accessing anything on the internet. It is built into most of the websites and apps that you probably use on a daily basis. And what I'm talking about, of course, is search. Search is, in my opinion, useful when we have a lot of content, when you don't want to scroll down a page for 10 minutes in order to browse and find what you're looking for. Search is also really useful when you have imperfect or only partial information, right? So if I were to go to an e-commerce store and I want to search for something to buy, maybe I know some aspects of what it is that I want to buy. I know that I'm looking for pants. I know maybe that I'm looking for blue jeans. But I don't know exactly what brand. I don't know exactly what's the name of the pant. I don't have a product ID to put in. So I need to search for it. I need to give the engine whatever information I have, and hopefully it gives me back what I'm looking for, if things go well. So, okay, we understand a little bit about why we need search and why that's relevant. So what characterizes good search? I would say that the first thing is speed. It's really important to have great speed when you're building your search. If you can return search results quickly, then your users are going to be happier. They're going to have a little bit less friction. They're going to be able to find what they're looking for quicker. That's obvious enough. If you can have very good speed, if you can return results in a matter of milliseconds, maybe tens of milliseconds, then you can actually start to create some pretty interesting experiences. Right? The behavior on the page will be a little different if you can return response that quickly. You don't need a loading spinner, right? You can have a more responsive page. It feels like the user is typing in something, and then the page is immediately responding to them. They're not being redirected, they're not waiting, so they tend to be a little bit happier. I would argue that the second characteristic of a great search experience is relevance. If you don't have good relevance, and if I can't find what I'm looking for, then I'm not going to be happy as a user. So I think relevance kind of speaks for itself. If you have very, very good relevance, maybe when I'm searching on my mobile app and my fat thumbs hit two keys that I did not intend to push, and I finish typing my query and I hit search, good relevance could be maybe typo tolerant, right? Maybe we can accommodate those fat thumbs and still produce good search results. So good relevance is very important. A third characteristic of a powerful search experience is infrastructure. If you have great infrastructure, hopefully a good distributed infrastructure, then you'll have servers that are close to all the groups of your users around the world, and they'll have less latency. That'll lead to greater speed. If you have powerful infrastructure, then you will have, hopefully, a reliable search experience that doesn't break. You can also have better scalability. So as your traffic grows and the server takes on more load, you will still be able to have a good, fast, relevant search experience. Having said all of that, building all of these things is hard. It takes time. It can often take a whole team of experts who have been doing search for a very long time, and maybe you need 10 of them, and maybe they're pretty expensive, and maybe it takes a while. So it's a little bit tricky, and for that reason, I would argue that the fourth characteristic of a great search experience is ease of integration, ease of development. So whatever kind of developer friendliness your product produces, that leads to a better and better search experience. But having said that, great search is hard, and it can sometimes take months. Having said that, I'm going to try to build a powerful search experience for you guys today in the few minutes that I have left. So begin the heckling now, please. So I'm going to build a search experience today using Algolia. And to get started with Algolia, there's three main steps that we need to follow. The first step is importing some data. Algolia is a hosted search API, so we need to host the data. We need to import that. The second step is configuring the relevance, right? We need to give the engine some clues as to how it should think about ranking your results. And the third step is actually building some kind of UI. So whatever it is that I want to deploy to production, how's it going to look, how's it going to behave? So those are the three steps that we're going to go through today. So for step one, let's import some data. I don't actually have any data to import, so I figured maybe we could grab some really quick. So I'll just Google fake user data API, and I already did this, so hopefully it still works. And here's a random user generator. particularly convenient because I can just navigate to this URL, and hopefully it will return 5,000 JSON objects, each one being a fake user. So as long as the Wi-Fi works. And I'll just save this. So this is the first step. We're going to have some data. We'll call it users.json. We'll save that to the desktop. And in fact, while we're here, we might as well create a new folder for our project, since we're starting from scratch. Call it demo. And inside of this, we'll save our users.json. The other thing that we're going to need is an Algolia account. Fortunately, I work there, so I already have one. And this is it. And we got an index that's empty and ready to go. So now that we have our data, it's sitting inside this folder here called demo. Let's pop open our text editor, and let's take a look. So here's our data. And it's probably going to be formatted a little funny, so let's clean it up. All we want at the end of this is an array of JSON records, so I'm going to kind of delete all this metadata that's sitting there. And if I've done this correctly, in theory, we have 5,000 JSON records sitting in this array. These are all our fake users. The next thing that we're going to want to do is we're going to want to import this data into Algolia. There's a few different ways of doing that, one of them being via the dashboard. So I could just drag this file into the dashboard, index it that way. I thought it might be a little bit more interesting if I actually write an import script to sort of illustrate how you might actually go about doing this in production. So I'll create a script called import.js. And while we're here, we're going to actually be leveraging the JavaScript API client that Algolia provides so that we can index things a little bit more easily. So why don't we actually start off by creating a new NPM project. We'll initialize it. We'll accept all the defaults. That should be fine. And it looks like we have a package.json file. OK, cool. So first technical issue with the presentation. I'm in the wrong folder. So let's open a new terminal tab. Let's navigate to the correct folder, hopefully. Yes. Is that good? Keep going? This is almost frighteningly big. Can everybody see? Cool. So it looks like we have our new folder set up. We have an import script. Let's actually require the module first. So we'll go npm install Algolia search, and we'll save that. So once this module is installed, we're going to use this to actually index our data. It looks like it has done so successfully. We have a package.json file. So far, so good. The next thing that we're going to want to do is we're going to want to actually require Algolia search. Hopefully I typed that correctly. We're about to find out in a few seconds. While we're here, let's actually pull up the Algolia docs, and let's follow the instructions on how we index data. So I'm going to pop open the docs. I'm going to use our own search. I'm going to look at the first article, indexing data, click on JavaScript, and hopefully I'll find a nice snippet that I can paste. Conveniently comes with my app ID, with my API key. So let's paste that here. Don't want to paste a bunch of dots, so let's grab our actual admin API key. Please don't tell anybody my admin API key. It's very secret. And we're going to target the index users. The next thing that we want to do is actually require the data that we're going to import. So let's call it data, and let's require that. Hopefully, I did that correctly. The next thing is going to be to actually call the method addObjects. That's going to take some data. It's also going to take a callback function. And following pretty standard convention here, we're going to pass in an error, some content. And first thing first, let's do a conditional check. Let's see if there's an error. Let's throw that error. And the next thing that we want to do is, if it succeeds and the data is correctly indexed, let's output a little message for ourselves. So we'll say import is complete. Hopefully that should run. real quick, I just want to come back here. I want to make sure I've actually initialized npm, because I see a package.json lock. I don't see an actual package.json file, so let's fix that. There it is. And let's reinstall Algolia. So that looks good to me. There it is as a dependency. Cool. So in theory, we have our API client, we have our data, and we're ready to run the script. There's one last little thing that I want to do. So Algolia provides an engine that's not based on Lucene. It's not based on any other open source technology. It's completely rolled from the ground up. And it applies a certain tie-breaking formula to actually rank your data textually. But it also allows you to rank your data in a way that has nothing to do with the textual relevance. It allows you to include certain metrics, so business metrics that are key to your product, to whatever it is that you're building. These metrics could be pretty much anything that you guys think is a good signal of quality for your content. So if you're an e-commerce store and you have products that you're selling, maybe a signal of quality might be the sales count. So how many items has this product sold? If you're a media company or a SaaS company, maybe you have other metrics that you're tracking, maybe something like page views or popularity, ratings, reviews, anything like that would work. In this case, we just pulled down a bunch of fake user data and we don't really have anything, so I'm just going to make something up. So let's take our data and let's actually transform it. Let's map over the data that we're importing, and for every single object, let's transform it very slightly. Let's say we'll add a score attribute, and we'll just give it a random number between 1 and 100, and that will serve as our business metric, our signal of quality. And then of course we have to return our object. So hopefully this runs. We'll find out in about 2 seconds, and if it doesn't, I'm counting on you guys to tell me where the bug is. So let's run this import script, and let's see what bugs emerge. Okay, no bugs, in theory. We don't actually know that yet. Here's an index called users. Let's refresh, and ta-da, we have 5,000 user records. So far, so good. We also see that each user has this score attribute that we just added. So we have some data. This is a good first step. I told you guys that the second step is going to be configuring relevance. I sort of cheated and actually configured some of the relevance ahead of time. I'll show you guys what I did. So on this tab inside the Algolia dashboard, this is the Browse tab, and there's actually a nice search experience built in directly here. So if I want to search for a user, I can actually start typing, and search results will populate. This is really useful because it gives us an opportunity to test different queries, and before we've actually even started step 3, we're already starting to see the fruit of our labor. We're already starting to see the relevance, and we're able to tune things. Something else that's pretty cool about this is that for any given search result, I can actually see the ranking information, understand exactly why it was ranked in the position that it is, which is really, really powerful when you're trying to iterate and trying to improve relevance over time. The way that I configured relevance was going to this tab. There are 2 important things that I want to show you in this tab. One is the searchable attributes, and this is simply where I've defined which attributes on my JSON records I want to make textually searchable. So not all attributes are going to contain content that a user is going to query for. So for example, for our user JSON records, we have image URLs. I don't know if anybody is actually going to come to a search bar and type in anything that is going to match on a URL. So we probably want to leave that out. But having said that, things like the person's first name, last name, email address, location, these are things that I could imagine somebody searching for. So I consider them textually relevant. I'll add them here. And I can order them in the order of importance. If I think a match on the first name is more relevant than an equal match on the email address, then I want to put name above email. And I've done that here. The second thing I want to show you here is the ranking formula. So like I was mentioning earlier, being able to understand your relevance and improve upon it is really important. So to that end, we consider ourselves a white box solution. What that means is that we try to make it really, really easy for you to understand why are things being ranked the way that they are. Very specifically by looking and understanding the different criteria that are being used to textually rank your results. The extra thing that I've added here is that custom score attribute that we've fixed onto all of our records. This magical arbitrary value that we've created. And what I'm telling the engine here is basically, once you have taken the query and you have determined what results are relevant based on textual relevance, let's also then use this score attribute to further sort our result set. And this is going to become really, really important when you're building a production search experience. Leveraging these business metrics is the only surefire way to know that you have great relevance beyond just textual. So that's it for configuring the ranking. One other thing I'll briefly touch on is this display tab. I've also indicated that there's a few attributes that the user in the UI might want to use to filter the results. So in this case, I've chosen things like nationality, city, state, so just some simple geographic data. But the important thing is I'm just giving a signal to the engine. These are the things that we're going to be using to filter the result set down. So at this point, I think we have data in the index, we have relevancy configured, so I think it's a good step, a good point to actually start building the UI and start doing the third step. To that end, I'm going to be using instantsearch.js. Algolia provides more than just an API. We provide a whole host of different tools around that API as well to help you guys get a good search experience up and running quickly and easily. There's a variety of different UI libraries that we provide to help build with. Some are very low level and put you right next to the JSON response from the API and let you do what you will with it. Some are very high level and they abstract away a lot of the complexity so that you can just kind of get up and running very quickly. I like instantsearch.js in particular because it is just that. It is a high level library and it's componentized. So I can just kind of grab widgets, put them into my JavaScript file, and it's magically just going to work. And that's what I'm after here. So let's start leveraging instantsearch.js. Let's actually build a UI. So I'll start off by creating an index.html file. And I'll tell you guys right now, nobody in this room probably wants to sit here and watch me write a bunch of HTML and CSS. So I'm not going to. Instead, I'm going to copy and paste a bunch of HTML and CSS. So here's our HTML. It's a very minimal HTML skeleton. It has a top of the page, the bottom of the page, the sidebar. A couple of key things to notice here. We've required our CSS. We've also required the instantsearch.js library client side. And we're also requiring our application JavaScript code. Let's go ahead and also create an app.css file. And let's copy and paste that too. So we've got some CSS. We've got some HTML. I also want this snazzy image here. It'll add a little color to our page. So let's paste the image. And the only thing really left for us to build is the actual JavaScript. So let's write that. So here's an app.js file. And let's slowly, methodically start copy and pasting little widgets into that file and talking about them to see what it is that we're going to do. The first thing that we're going to do is instantiate the JavaScript library. You're going to notice here my app ID, my API key. This is actually a search-only key, so it's safe to serve in the client. So you're not going to be able to do much with this, but if you did notice the admin API key, you will be able to, at the very least, annoy me during this demo. Please don't do that, but at the same time, if you do it, it might be fun, so we'll find out. The other thing that I'm specifying here is some facets. So I'm giving a clue to the client-side library. These are the things that we might want to filter on shortly. The next thing that I'm going to add is a search box widget. Again, I want to emphasize that these are all widgets that are effectively just being copy and pasted from the Instant Search library and the documentation on the website. The only thing that I've done here to actually configure these things, it's very minimal. I've specified a container for my search box, so that's where the input is going to render. And I've specified some placeholder text. Give a little context to the end user so they know what they should search for. Let's add a stats widget. That will tell us how long our searches are taking. It'll tell us how many results we have. Again, a little bit of context on the page for the user. That never hurts. The next and final widget that I'll include right now is going to be the results widget, or the hits widget. And this is where the hits are going to render. Again, very minimal configuration. In this case, I'm specifying a container. I'm specifying a transformation. We just want to grab one of the attributes on all of our JSON records and make the date a little bit more human readable. And then we're specifying some templates. I told you guys we wouldn't do too much HTML today. So I'll just say that these two templates, one is for when there's no search results, one is for when there are search results. Here's the HTML template that we're going to use to render each hit. And these are the locations where we're going to actually inject some of that JSON data into the template. And the last thing that I want to do is call search.start. And that's it. I should have basically successfully built some kind of search experience with this code alone. I'm going to run this in the browser, and we'll see what breaks. So right off the bat, we got a search bar. We have our fancy image. And we have some results. So that's good. We have a nice base state. We're also seeing that we have 5,000 results and that they were found in 1 millisecond. That was the engine taking 1 millisecond. I don't know about latency or Wi-Fi or any of that stuff. That's outside of the scope of what I'm going to think about or talk about on this occasion. So now that we have that, it's pretty cool, but I think we can maybe go a little bit further in the time that we have. So why don't we add a couple more widgets? I promised you guys that we would have the ability to filter in the UI, so I'm going to add some refinement list widgets. So again, I'm just going to paste these widgets directly from the documentation with a little bit of configuration. What container should I be rendered in? What attribute should I use to filter with? And that's basically it. So we're going to save that. We'll rerun this. And magically, we have some refinement lists on the side. So now we're able to filter by country. We're able to filter by state. So if I'm going to search for a user here, let's say I want to find maybe, is there a user in this group of 5,000 named Bob? I can start typing in Bob. Already with BO, I'm starting to see some Bob-like names. Maybe I also want to restrict my search and only search within a subset of the data. So that's what these filters are for. Let's say I want to find a Bob who lives in the US. So I'll type in US, and I can actually search for facet values, and then facet on US. So now I'm only seeing Bobs in the US, and when I complete the query, we can see all the Bobs in the United States, according to our data set. There's maybe one other thing that I want to add, and that is the ability to paginate. We have currently the ability to render in an empty state. We're rendering about 20 records here, and we have 5,000. So let's add the ability to paginate just because. Again, I'm pasting in, I'm specifying a container, that's it. And when I refresh the page and scroll to the bottom, we now magically have the ability to paginate. That's it. We just built a search experience. I would say that the search experience is fast. I would argue that it's relevant. I would say that it's backed by fantastic infrastructure. And I would argue that that was pretty quick and easy to set up. There's a lot of places that you can go from here. There's a lot of different features that Algoy provides that go way beyond just a search bar and the ability to filter and facet. Features like personalization, features like conditional logic at query time. There's a whole host of these, and there's a whole slew of different things that you can build that go way beyond just a search bar and a refinement list. Things like voice search, a lot of different examples. I'll save those for afterwards. If anybody has questions, please feel free to find me after the talk, and we can chat about those. So as far as what clients have done, that's a very big conversation. There's a lot of different ways that you can use personalization. I would say that there are maybe two main camps that they would fall into. One form of personalization is very general. It's very broad. It's the ability to personalize on an attribute-like category, right? So if a user comes to your page and you know a little bit of contextual information about that user, maybe you know their search history, maybe you know some kind of preferences that they have. And in that case, if you know that X user likes pants, for example, then you can personalize on a category level. You can say that when they search, let's return all the results that are relevant to what they've typed in, but let's boost any of those results that happen to be pants. That's the general way to personalize. There's a much more granular and specific way to personalize, and that is at the individual user level. So if you have that user's ID, and that particular user has maybe saved some favorites, right? As they're browsing your site, they've starred certain items, or they've added items to their cart. This is something that is unique to this user. It is not a category that a lot of users might like, but rather it is a specific subset of data that kind of belongs to this user in a certain way. In that case, you can also personalize on the user ID. So that would be another way that personalization tends to occur. I would say those are the two most common patterns for personalization.
Thank you, Sepehr.
Cool.